In this video, we're going to prove the result that every graph has an even number of vertices of odd degree. So, first, recall the Handshake Lemma, which is one of the fundamental lemmas of graph theory, which states the sum of the degrees of the vertices of a graph is equal to twice the number of edges in the graph. Okay, so this is the fundamental inequality, or equality, I mean. And now consider the Handshake Lemma mod 2. We know we have 0, 0 is congruent to 2e. I mean, perhaps first we should say let G equals VE, so the vertex set is V and the edge set is E, be a graph. Now consider the Handshake Lemma mod 2. 0 is equivalent to 2e because 0 is even and 2e is even. And this is equivalent to the sum of the degrees of V. And this sum is over V. Okay? Now, the next equivalence, we're going to have to define two new sets. We'll say let V even, or VE, be the vertices of V with even degree, and V O be the vertices of odd degree. Okay? Now here we can split up the sum into the sum over VE of the degree of V plus the sum over V of VO, so the odd degree vertices, and this is somewhat clearly equivalent. We'll say V in okay, and then in the other case V in VO. Okay, and now we can actually get rid of the first part of the sum. So this sum over VE, because all the degrees are even, we know that they're all 0 mod 2, and thus they contribute nothing to the sum. So here we can tell that this is, we want to show now that this, from this final equality, that we must have an even number of these vertices. Okay? And now, mod 2, all of these vertices, since they're all odd, these are all equivalent to 1. Okay? And so, what this is equivalent to is equiv the size of VO. Yeah, this is equivalent to the size of VO. And now since we know 0 is equivalent to the size of VO, the size of VO must be even.